Now in this lecture we will find the values of x and y. In the drawing we have a shape, and we note that the area of this white shape equals to 240 units squared, and the width of this shape is 15 units, and the length of this shape is 20 units. And we want to find out the value of x and y. First of all, we will give names to the vertices of this white shape. We will define this vertex as A, this vertex will be defined as L. Again, this vertex will be defined as L. This vertex will be defined as C, and this vertex will be defined as D. Okay? In the next step, we will extend line segment X to a size of 20 units. Okay, we will extend line segment X to a size of 20 units. And then we will lower perpendicular from this point to line segment CD of this shape. So we lowered perpendicular from this point to line segment CD of this shape. So actually we will define this vertex as point B, and actually angle LBD will be equal to 90 degrees because of the fact that AL is parallel to CD, so the vertex that we lowered, the perpendicular that we lowered to CD is also perpendicular to AB. Okay, so actually angle BDC is 90 degrees, and also angle DBA is also 90 degrees. Again, we extended line segment X to a size of 20 units, and from point B we lowered perpendicular to line segment CD of this shape. So actually angle CDB is 90 degrees and angle DBL is also 90 degrees. So we actually created a rectangle because shape ABCD is a rectangle because of the fact that AB is parallel to CD, and also AC is parallel to BD, and it also equals to BD, it equals to 15 units, and also AB is equals to CD, it also equals to 20 units. For that reason, the shape ABCD is a rectangle. Okay? So actually the area of a rectangle area of the area of any rectangle and equals to the length of the rectangle times the width of the rectangle. So the formula for the area of any rectangle is actually the length of the rectangle times the width of the rectangle equals to the area of any rectangle. Okay, and especially the area of rectangle ABCD will be equal to the length of ABCD. The length of the rectangle ABCD is 20 units times the width of the rectangle ABCD, that is 15 units. So the area of rectangle ABCD that we created actually will be equal to 300 units squared. Okay, so the area of rectangle ABCD that we created equals to 300 units squared because it equals to the length of the rectangle, that is 20 units, times the width of the rectangle, that is 15 units. So 20 times 15 is 300 units squared. So the area of rectangle ABCD equals to 300 units squared. And actually the area of the rectangle minus the area of this white shape will be equal to the area of the right triangle. Okay, so the area of the right green triangle will be equal to the area of the rectangle minus the area of the white shape, or the area of the rectangle minus the shape ALCD. Okay, the area of the rectangle minus the area of the white shape equals to the area of the right green triangle. Okay, so we can write down that the area of right triangle LBD, the area of the right green triangle LBD, will be equal to the area of the rectangle ABCD, that equals to 300 units squared, minus the area of the white shape, that equals to 240 units squared. It is given us that it equals to 240 units squared. So 300 minus 240 equals to 60 units squared. So the area of the right green triangle LBD equals to 60 units squared. Okay, the area of the right green triangle LBD equals to 60 units squared. So I will draw triangle LBD again. Actually, the size of LB equals to 20 units minus x. Again, the size of LB, the size of the side of the right green triangle LB equals to 20 units minus x. Okay? But we also know that the area of the right green triangle equals to 60 units squared. So I draw again the right triangle LBD, and we actually know that the area of this right triangle equals to 60 units squared, and we know that side BD of this right triangle equals to 15 units, and side LB equals to 20 minus x units, and LD equals to y. So we actually can use the formula for the area of a triangle in order to find out the value of x. Okay, so the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. So the formula for the area of any triangle in the world is actually the base of the triangle times the height to the base over 2. And you should remember that the height to the base must create 90 degrees with the base. So the height must be perpendicular to the base. Okay? So we actually can calculate the area of this right triangle LBD according to the formula that calculate the area of a triangle, that is the base times the height over 2. So the area of triangle LBD, right triangle LBD, will be equal to the base of the triangle, that is actually 20 minus x, times the height to the base. The height is 15 because the height BD that is 15 is perpendicular to the base LB, so the height of this right triangle is 15 units. So it is 20 minus 6 the base times the height that is 15 over 2. Okay, so the area of the right triangle LBD equals to the base that is 20 minus 6 times the height to the base over 2. And as you can see here, the height dB that equals to 15 units is perpendicular to the base. Okay, the height must be perpendicular to the base, and you can see here that the height dB that equals to 15 units is perpendicular to the base. Okay, so this is the formula for the area of this right triangle LBD, but we know that the area of the right triangle LBD equals to 60 units squared, so we can substitute the area of LBD by 60 because it equals to 60 units squared. Okay? Okay, so I substituted the area of LBD by 60 because it equals to 60. The area of triangle LBD equals to 60 units squared. So we got that 60 equals to 20 minus x times 15 over 2. We will multiply equation number 1 by 2. So we multiply this equation by 2. 60 times 2 equals to 120, and 20 minus 6 times 15 times 2 divided by 2 equals to 20 minus x times 15. Okay, 2 is cancelled and we left with 20 minus x times 15. Now we will open the brackets in this equation. So we open the brackets in this equation. 20 times 15 equals to 300, and x times 15 equals to 15x. Now we will subtract 120 from this equation. So we subtracted from this equation 120. 120 minus 120 equals to 0. And 300 minus 120 equals to 180. So in total we got that 0 equals to 180 minus 15x. Now we will add 15x to this equation. So we added 15x to this equation. 0 plus 15x equals to 15x, and 180 minus 15x plus 15x equals to 180. Here we will divide this equation by 15. So we divided this equation by 15. 180 over 15 equals to 12 units. So x equals to 12 units. X, the variable that we wanted to find out, is equals to 12 units. So if x equals to 12 units, then 20 minus x equals to 20 minus 12, that is to say to 8. So in this right triangle, we know that the perpendiculars of this right triangle equals to 15 units and 8 units, and the only missing variable is the hypotenuse of this right triangle. So we can use the Pythagorean theorem in order to find out the value of y. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is actually y square equals to the sum of the squares of the perpendiculars, equals to 15 square plus 8 square. Okay, so according to the Pythagorean theorem, the square of the hypotenuse, that is to say y square, equals to the sum of the squares of the perpendiculars, equals to 15 square plus 8 square. Okay, so 15 square is 225 and 8 square is 54, so I write it down. So we have the equation that y square equals to 225 plus 64, 225 plus 64 equals to 289, so I write it down. So we got that y square equals to 289. Now we'll take a root out of equation number 3. So the square root of 289 equals to 70 units, so y equals to 17 units and x equals to 12 units. So the answer to the question is that x equals to 12 units and y equals to 17 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the values of x and y in this y shape. We know that the area of this y shape equals to 240 units squared, and the width of this y shape equals to 15 units, and the length of this y shape equals to 20 units. And we want to find out the values of x and y. So actually we gave names to the vertices of this y shape, and then we extended line segment x to a size of 20 units, and then from point B we lowered perpendicular to CD, to line segment CD. Actually, in this way, we created a rectangle, and the area of any rectangle equals to the length times the length times the width times the length, or the length times the width. Okay, the area of any rectangle equals to the length times the width, and the area of this rectangle ABCD will be equal to the length, that is 20 units, times 15, that is the width, of the area of triangle of rectangle ABCD equals to 300 units squared, and the area of the right green triangle will be equal to the area of the rectangle minus the area of the white shape, or the area of triangle LBD, the right green triangle LBD, equals to the area of the rectangle, that is 300 units squared, minus the area of the white shape, that is 240 units squared. So the area of triangle right green triangle LBD equals to 60 units squared. Okay, the area of the right green triangle LBD equals to 60 units squared. Okay, so I copied again the right green triangle LBD. We know that the area of this right green triangle of this right triangle equals to 60 units. This side equals to 15 units, and the size of LB equals to 20 units minus x. Okay, the size of LB is 20 units minus x, and we actually use the formula for the area of a triangle in order to find out the value of x. And the area of a triangle equals to the base of the triangle times the height to the base over 2. You should remember that the height must be perpendicular to the base. Okay, so the area of triangle, right green triangle LBD equals to the base of the triangle, that is 20 minus x, times the height. The height is dB, that is 15 units, because it is perpendicular to the base. So the height of this right triangle is dB, that equals to 15 units. So the area of triangle LBD is the base of the triangle, that is 20 minus x, times the height, that is 15 over 2. And we know that the area of triangle LBD is 60 units, so we can substitute the area of triangle LBD by 60 because it equals to 60 units squared. So we substituted the area by 60 units squared. We got that 60 equals to 20 minus x times 15 over 2. We multiply the equation number 1 by 2, and in the end we got that the x equals to 12 units. X equals to 12 units. So if x equals to 12 units, then this side LB will be equal to 20 minus x, that is 12. 20 minus 12 is 8 units. So in this right triangle, we know that this side equals to 15 units, side LB equals to 8 units, and we can use the Pythagorean theorem in order to find out the value of the hypotenuse of this right triangle that equals to y. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually the square of the hypotenuse is y square equals to the sum of the squares of the perpendiculars, equals to 15 square plus 8 square. So our further question states that y square equals to 15 square plus 8 square. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, equals to 15 square plus 8 square. So we solved this equation and we got that y equals to 17 units, and we have already found that x equals to 12 units. So the final answer to the question is that the value of x is 12 units and the value of y is 17 units. Okay, thank you very much.